Hi, my name is Weng. Now I'm going to present the computer programming group project, production planning, lathe, mill, and drill machine. We are from the group 2. Our group leader, DHARVINDARAN, and then member DIVIYA, RUBAN, me, and GANAHCAN. Now let's go to the introduction. First, I will talk about the objective. In this group project, the objective of our group is to understand the conventional machines and its operation, lathe, mill, and drill. Then we need to propose 3 suitable metal products to be fabricated using 3 different operations. The complete and detailed steps of each operation will be shown in the report, and the programs will be developed for each respective operation using Dev C++. These programs are needed to assist the mega metal company to improve their productivity planning by guiding them in operating the lathe machine, mill machine, and drill machine. The operation analysis will be done in the report, including the steps involved, total part machining time, total energy consumption, total operation cost, byproducts or solid waste generation in kg, and estimated productivity per 8 hours working. Now I will talk about the lathe operation. Lathe operation is run by using a lathe machine which rotates a block of material to perform various operations such as cutting, sanding, kerning, drilling, or deformation with equipment that are applied to the workpiece to create a product which has symmetry about an axis of rotation. The lathe is used for a large range of purposes such as shaping solid materials. For example, a metal, the workpiece was placed in between the tailstock and the headstock. The material is then spun and curved to make different dimensions by controlling the shaping tool. Lathes are also used to cut threads, drill different shapes like conical, cylindrical, mill ends, drill and bore openings, among many other functions. Lathes can be controlled manually or with an auto system. Now let's talk about the milling operations. Milling is the process of cutting a workpiece by rotating the multi-tooth cutting tool. It is known as a milling cutter, and the edges of the cutter are called teeth. Milling is a linear process where the workpiece is stationary while moving the tool. Milling is a versatile process and able to conduct simple 2D flat shapes to a complex 3D surface. Milling is also a useful operation to produce different shapes from a workpiece. Different types of machine and type of milling operation use different type of milling cutters. For example, a plain milling cutter is used for peripheral and slab milling. Milling machines are used widely in the metalworking industry due to its capability to work in a wide range of metals, ranging from aluminum to stainless steel. Milling machines also can be used for complicated cutting operations, from slot cutting, threading, and repeating to routing, planing, and drilling. Other types of milling machines are knee-type milling machine, universal horizontal milling machine, ram-type milling machine, universal ram-type milling machine, and swivel cutting head ram-type milling machine. Now let's talk about the drill operation. A drill machine, or we call drill press, is operated to cut holes into solid materials by using a drilling tool with cutting edges. This cutting tool is held in a drill press by a chunk of Morse taper and is rotated and fed into the work at variable speeds. Besides cutting holes, drilling machines can perform other operations including countersinking, boring, counter boring, spot facing, reaming, and tapping. To operate the drill press, it is necessary to have some training for workers to set up the work, set speed and feed, and provide for coolant to get an acceptable finish. The size and capacity of the drill machines is usually determined by the largest piece of stock that can be center drilled. For example, a 15-inch drilling machine can center drill a 30-inch diameter piece of stock. Other ways to determine the size of the drill press are by the largest hole that can be drilled, the distance between the spindle and column, and the vertical distance between the worktable and spindle. For fabricating parts purpose, there are 2 types of drilling machines available, which are the hand-fit and power-fit drilling machine. Multiple spindling drilling machine, gang drilling machine, and turret drill presses are all variations of the basic hand and power-fit drilling machines. They are all designed for high-speed production and industrial shop. The hand-feed drilling machines are the simplest and most common type of drilling machines. These machines are used to handle the light work using feed handle. Compared to hand-feed, the power-feed drilling machines are larger in size and greater in weight. They are equipped with the ability to feed the cutting tool into the work automatically. At the present depth of cut per revolution of the spindle, usually in thousands of an inch per revolution. These machines are used in maintenance shops for medium duty work or work that uses large drills that require power feeds. And that's all for the introduction from me. Thank you.
A very good day. I would like to wish to our lecturer. My name is Divya Annaprampan Gumanan. My matrix number is CD200089, and today I'll be presenting on behalf of our group project assignment. So, for this group project, my part is about late machines. So I will start with the specification of late machine. So for this project, the late machine model we have chosen is C0632B, and as for the spindle range, it's 8, and but the precision, it's very precise. The specification, that means the measurement of this late machine, is 1570 mm times by 750 mm times by 1240 mm. And if you see the maximum length of this workpiece that can be shaped in this using this lathe machine is 750 to 1000 mm to the max. The spin, as we see, for the spindle speed is 770 to 2000 rpm, and same goes to the steps of spindle speed is the same. Spindle speed and the steps of spindle speed. As we go for the next part, range of longitudinal feet, it is 0.026 to 0.348 mm per hour, and range of cross feet is equals to 0.07 to 0.94 mm per hour. And if you look to the net weight or gross weight, it is 495 to 595 kilogram. Okay. Then that's all for the specification of lathe machine. Next, I would be presenting about calculation and design. So basically, for the design we have chosen, we have two calculation, where first is cutting speed. Cutting speed, the uh, formula, for the short term is V. So the formula is V is equals to pi d n divided by 1000, and the SI unit for this is m per minute. Okay, so when I would elaborate little more about the formula. D in this formula means the diameter of work in mm, and the N is RPM of the work. So, as I've done in this part, there are three parts for the workpiece. So, for the first part, for the first part, the N value is 70 RPM based on our late machine specification, and the D is 35 mm. That means the first part, the D1 is 35. So when we substitute in the formula, V equals to pi, D will be 35, and N will be 70. Divide by 1000, I'll get 7.697 meter per minute. As for that goes for part 2 and part 3. So for part 2, when I substitute the value, the D value is 25 mm. When I substitute the value, I'll get 5.498 meter per minute. And for the last part, the D value is 16 mm. When I substitute the value, I'll get 3.519 m per minute. Next is depth of cut. It is modified as T. So the depth of cut for the workpiece will be, the formula will be D1 minus D2 divided by 2, where D1 is the surface before machining, D2 is the one, the end measurement that we need. So for this one, we won't be disturbing the first part. We will only machine for the part 2 and part 3. So the second part will be, the initial diameter would be 35 mm, that we will be machining it to make it 25. So 35 minus 18 divided by 2, we will get 8.5 mm. So that's the value we will be machining. And as for the part 3, the same thing, but then when the value for D1 and D2 will differ, whereby D1 in this part will be 25 mm and D2 for this part will be 16 mm. So as we substitute the value in the formula, we will get 4.5 mm. So that's all for the calculation part. Um, Next, that's all from me.
Okay,
Thank you so much.
my name is GANAHCAN, CD 2018, and I'm going to be presenting on the milling machine. So this is the machine type chosen to do a milling machine with a spindle motor power of 7.5 kilowatt, and the spindle speed is from 50 to 8000 rpm, and the feet rate is 1 to 7000 mm per minute. So to fulfill this project's requirement, we have to calculate the cutting speed, machining time, the total solid waste, and the productivity per 8 hours of working time, and the total energy consumption. From here we will show this so from formula we know cutting speed is VC equals to pi times diameter cut times spindle speed divided by 1000, and machining time is total length divided by the table feet per minute. So goes the solid waste is volume that we have cut, the total volume of a cut, then productivity is the machining times with the spindle motor power. So you get the total energy consumption, and productivity is machining time times the 8 hours. Then you get
My name is Darvindaran. My metric number is CD200107. So now I'm going to talk about drilling machine specification. Drilling machine are specified according to their types. In this report, we are going to use bench type of drilling machine. So these are the specification of the bench drilling machine. This machine motor power is 750 kilowatt and the rated voltage is 220 volt 50 Hz. In this machine, we can set the speed level 1 to 12 speed. The spindle speed we can use 300 to 2550 rpm. The maximum size of drill that can be accommodated by machine is 16 mm. The output shaft to workbench surface is 340 mm, which means the workbench can adjust up and down until the limitation. The table size of this machine is 260 mm and the weight of the machine is 850 mm. Next, I'm going to talk about the design of the product and the calculation. So this is the design of our product we made from drilling machine. The material that we use is stainless steel and the size of material is 80 times 60 mm. We did 2 holes for this workpiece which are 12.3 mm diameter. The drilling depth we use is 20 mm, which is fully makes holes because our workpiece height is 20 mm. From the drill bit RPM chart, we set the spindle speed and the feeds, which are 552 RPM and 0.1 mm per rev. Next, based on the formula of cutting speed, which are VC equals to pi times DC times N over 1000. So the DC is drill diameter and the N is spindle speed. We can find out our project cutting speed, which are 21.32 meter per minute. So the mathematical formula is very useful for us to find the answer. So next, for the spindle feet and machining time also same like that. The spindle feet formula is VF equals to FR times N. So in this case, FR is feet per revolution And for machining time formula is Tc equals to Id times I over N times Fr. In this formula, Id is equal to the drilling depth and I equal to the number of holes. So from that formula, we get spindle feed which is 55.2 millimeter per minute, and the machining time is 43.8 seconds. Now I'm going to talk about the codings. These are the codings for our drilling machine. We used Dev C++ software to create the coding for this report. From the knowledge of computer programming subject, which we taking in this semester, we insert the data for these codings. From the output of coding, we can get the operational analysis, which are spindle speed, machining time, solid waste, generation per unit, productivity per 8 hours, and the total energy consumption.
Conclusion and limitations or problem faced. Lathe machine can use in a lot of professional fields. Limited work area. The work area is the distance between its two centers. Material limited to deal with only soft metals. Functionality limited to performing only specific operations. Mill machine will give you the information to make the most informed decision for manufacturing. One common complaint is the cost. The measurements of the part you have machined may have limitations. The operator has a significant level of control over the accuracy. Drill machine. Limited sized workpiece can only be machined. The drill may break. Cheap cutting lips can be performed.